Hello everyone, this is Mr. Attune. I am creating this video for Thursday, October the 14th. I may play this video in future years, but I'm basically creating this video just in case I'm absent again. That way you can still go ahead and you can complete the lesson. So, let's do the activity. So the expectation is that you're filling stuff in as we go through it. From time to time, I'm going to ask you to pause the video and complete the math. And then we're going to go through it together, just like we would in class. Are there ways you can cheat? Absolutely. Don't pause the video. You're just going to see the answer. At the very least, you should be filling out your data sheet, even if you're not trying to solve these on your own. Now, here's the catch. If you run the video completely through, on GoGuardian, the video is going to show that you get done really early, and you're going to have to get more IXL done. So if you don't follow directions, then you have an hour and a half of class, and it looks like the video finished in 25 minutes. Now I'm expecting you to have 2 or 3, maybe even 4 IXLs done. I am going to monitor GoGuardian. If you are off task, if you're watching videos that you're not supposed to, you're going to be out of groups for a while. Might be a day, might be 2 days, might be a week. I am getting pretty close to the point where I'm going to go back to telling some of you you can't sit next to each other because you struggle paying attention if you're by each other. So let's get back to the lesson. One other thing, I may be in class tomorrow, and if I am in class, I'm probably still going to have you go through this video just because I think it's good practice to have you guys not be guided through every lesson and some of the lessons that you have to learn on your own. So here's the learning target. We will write linear algebraic equations relating to figure numbers of a geometric pattern and its number of tiles. You will also identify connections between the growth of a pattern, its starting values, and its linear equations. So as I mentioned in the last class, solving for a variable is one of the keystones to doing well in algebra. We're going to start the other keystone. You have to be able to look at linear relationships, and you have to be able to make all kinds of connections. For example, if I give you a graph, you should be able to make an equation from a graph. If I give you a graph, you should be able to make a table, or you should be able to explain a situation related to that graph. Likewise, if I give you an equation, you should be able to graph it. You should be able to create a table. Or if I give you a situation, say, it's kind of like a story problem, you should be able to create a graph, a table, and an equation from it. So this chart shows you all the different things you have to be able to do. Go from a table to an equation, from an equation to a graph, or from an equation to a situation, and back and forth. So there's a lot going on, but yet we're going to work through these step by step by step through this unit. So, seeing growth in linear representations. Throughout this chapter, we're going to explore the multiple representations that I just talked about. And these are all of linear relationships. You will use the growth and the starting value of linear relationships to find a specific connection between situations, tables, graphs, equations. The specific situations you will work with today is the growth of tile patterns. So we're going to be working with patterns. So when we look at this could be your situations. This could be, patterns and how are we going to, well, we're actually going to get an equation, and we're going to work on graphing, I believe, later in this chapter, and we're definitely going to work with some tables. So we're going to work with quite a few of them. So we're going to work with the situations first. So these are some questions to keep in mind. How can you see the growth? What is the starting value? And what is the connection to the equation and to the table? So here's your first problem that you have on your sheet. And your work may be in different spots. It doesn't look exactly like this, nor has it ever. But we're going to work through A, B, C, and, well, D and E, and we're going to work through all of them together. So the first thing I want you to do is, what do you notice about the pattern? After everyone has had a moment on his or her own to examine the figure, discuss what you see with your team. So you're going to look at here, figure 1, figure 2, and figure 3. How is it growing? What do you notice about it? So go ahead, pause the video, and discuss these ideas with your team. All right. So what did you notice? Now, first of all, this is what I'd really like to see with your group. So as you're doing this, are you counting out how many there are? 1, 2, 3, 4, 5, 6. So there's 7 here. What is it? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 here. How many are in this next one? Did you count? 3, 6, 12. What is there? 13, 14? Let's count again. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, 13. I almost miscounted. Now, I want you to do things like this. Another really cool thing that I'd love for you to start doing and getting a habit of is looking at how it grows. So when we look at this one right here, notice that this one is added and these two are added. So let's look at this one right here. So there's 2 of them here. Did you notice that they added this one? And what does it go up? It goes up 4, 1, 2, 3. So that's where they added on. So when I look at this, I notice it's going up by 3 here. And it's growing 1 here and 2 each time in that. And that's how they get to 3. So those are the type of things I hope you discussed with your team. Now let's look at B. Sketch the next figure in the sequence. Figure 4 for pattern A on the grid. And then you're going to do figure 0. And figure 0 is the name of the figure that comes before figure 1. Sketch figure 0. So we're going to sketch both once. So this is where you have to look at how it's growing. Now, did you notice 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. So they all have 6 at the base. So if I'm going to draw figure 4, I'm going to start kind of low, and I've got to count out 6 of them. So I'm going to start here. 1, 2, 3, 4, 5, 6. So I know it's going to look something like this if I'm sketching out figure 4. And I'm going to name it 4. Now, this figure 3 goes up 3, figure 2 goes up 2, figure 1 only has 1. So figure 4 is probably going to go up how many? If you said, oop, a little awkward there, trying to draw with the mouse here. So if you said, oh, it goes up 4, you're right, because it goes up 1, 2, 3, 4. So that's another pattern. Now let's look at this right here. 1, 2, 3, 4, 5, 6. Now you notice it goes up 2 each time. So if I go up 6, 1, 2, 3, 4, 5, 6, that's what it was before, but how much does it grow each time? If you said, and you look up above, said, oh, it goes up 2 each time, I'm going to go up 2 more. So these are the types of things I would expect you to be able to do. Now, that's your figure 4. What is figure 0 going to look like? Well, we have to work backwards. Okay, so if 2 of these are added each time, let's do this. Let's use a dash line. So if I have to work backwards, I can cross that off, and I can cross one of these off, because remember, you remove 1 here each time, and then you remove 2. So now if I start to look at this, what am I left with? 1, 2, 3, 4. So figure 3, or figure 0, I'm sorry. 1, 2, 3, 4, is that right? So does that make sense to you? So again, if we're working backwards, I'm going to label that 0, and I'm actually going to put an F here. So we know it's figure 0, and this is figure 4. So by moving forward, we know that 1 was added, then 2, then 1, then 2. So if we work backwards, this is what we have. So now I've finished with B. So let's look at C. By how much is tile pattern A growing? So go ahead and pause the video and see if you can come up with an answer with your team. All right, what'd you guys come up with? How much is it growing? Well, if you said it's growing by 3, that's awesome. And you see how it's up here? So when you have to look and examine tile patterns, if you draw all this stuff out to begin with, a lot of your answers are going to be easy because you know how to find these based on your drawings and what you've already observed. So where are the tiles being added with each new figure? So I'm going to have you go ahead and type this out and then restart the video. All right, so did you type it out? Let me see where this starts typing. Yep, 2 tiles are added. I'm going to shrink this a little bit. All right, so 2 tiles are added on the top of the far right column. Did I spell that right? I didn't spell that right. That's the neat thing about spell check. Column. 1 is added to the, or 1 is added to the top of the far left column. So yeah, so 1 is added to the far left column each time, 1, and 2 is added to the top of the far right column each time. Now it says color in the new tiles in each figure with a marker or colored pencil on your resource page. So use a pencil or use a pen to do this. But did you notice what we already did? In A, by drawing in all this stuff and analyzing what you see, it's already done. So I've added, it's added here and 2 here. It's here and 2 here. So yours should basically look like these 2 right here. So color in the new tiles in each figure. So again, this goes a lot faster if you analyze in great detail to begin with. So let's move to the next page. It's my next page. It's not your next page. This is all on your front page. What would figure look like for pattern A? So you don't have to draw it. What would it look like for pattern A? Describe it in words. How many tiles would be in figure 100? Find as many ways as you can to justify your conclusion. Be prepared to report back to the class with your team's findings and method. So go ahead, pause the video. What do you think figure 100 would look like? Describe it in words. How many tiles would be in the 100th figure? So go ahead, pause the video. All right, so I'm assuming you've already calculated this. Now here's the thing. There is no right or wrong, well, there is a right answer. However, right now, I really don't care what your answer is. What I care about is, did you look into it? Did you study the pattern? Were you trying to figure out what it's going to look like? Now, we can start to look at a few things, and I'm not going to go through and type up an answer because all of your answers might be different and they might be correct. For example, here there was 1, then there was 2, then there was a 3. So we would know that figure 100 would have 100 going up on this side. We would also know that it's going to be, 6 wide. And we can start to take a look at how high this side's going to be. And we can start to take a look at, gee, this was 7, this was 10, this was 13. And we can count up by 3s all the way to the 100th figure. Now we're eventually going to learn a new way of doing it that's going to make it a lot easier. And you're going to learn that in a few minutes. So make sure you have something for D. Now the last thing we have to do today is write an equation that relates to figure number X to the number of tiles Y. And this is the important part. Make sure you listen to this and make sure you understand what we're doing. So whenever we do these equations, it's a linear equation. It's going to be written in this format. Y equals mx plus b. So they're always going to be in this format. And when I look at these, this is what they mean. X is just a variable. And if I multiply X by number and I add B, I get Y. That'll make a little bit more sense in a little bit. But what is M? M is going to be what we call the slope. So M is the slope. And B right here is going to be the y-intercept. Now, you may not fully understand this today. You may have to take 2, 3, 4 lessons to figure out what's going on. But if you listen to this, it might click after day 1. So I'm going to show you how you find this. So my equation is going to start with a y. It's going to have an mx, but I'm going to leave the m blank for now. And it's going to have a plus b. We're going to leave that blank for right now. So the m is the slope. So you find a slope right here. The slope is what it goes up by each time. So it went from 7 to 10, it went up 3. Went from 10 to 13, it went up 3. So if you looked at figure 4 down here, you already know what it's going to have. It should have 16 tiles. Why? Because it keeps going up by 3. So when I look at this, this is where I'm going to write my 3. Now here's the neat thing. What's going to be your B? Your B is your y-intercept. And when you look at a tile pattern like this, the y-intercept is going to be this right here. 1, 2, 3, 4. Whatever figure 0 is, whether it's in a drawing like this or whether it's on a graph, it would be where it crosses the y-intercept. But if it's in a data table, whenever x is 0, whatever your y is, you know, that's going to be it. So I'm going to write this down as 4. So again, this may not make complete sense, but it's a good start. So what I'm going to do is I'm going to stop this video here, and this took you through the first problem that we did. So I'm going to post the second video with the next problem. So make sure you understand what this is. If I am in class because I didn't have to be gone, you know, come and ask for help if you need it. Otherwise, make sure you watch this video.